Hi guys, we are going live, and today's the next week of our freeze lab and the new topic according to binary search. So let's go start it, and our first task will be the following. Okay, so our first task is about missing numbers. Yeah. What do we mean? So we are given some array nums containing n distinct numbers in a range from 0 to n. And we should return the only number in the range that is missing from the array. Nice. So about understanding, we have some array. Let's say 1, 3, 4, 5. That is missing. Okay, so 1, 3, 2, 4. Yes. And since our n is equal to 4, right, we are missing actually number 1. Yeah, here, because we have values from 1 to 4. Okay, when we have, for example, empty array, what will be our result? When we have empty array, should we return -1? I think in this case, yeah, probably it's not valid. So we at least have one element. And what would be like when we have 4? So when we have 4, it's also not valid value in our array. Okay, so let's take another one. So when we have, for example, 1 and n is equal to 1, right? So in this case, probably we are missing 0 because we're starting from 0 inclusively and inclusively 1. Yeah, so it's valid this case. So within this, let's talk about constraints that we can have. So the first constraint is our array length. So our array actually, yeah, can be like 10 in 5th power, let's say. So from 1 to 10 in the 5th power. So because 1 is, I think it's valid this case, but 0 is not valid this case. Also, we have valid numbers in the array, right? Yeah, add our values actually from 0 to n. And n is actually array length. Okay, so I think it's pretty much all constraints that we have. Well, let's think about solutions. First solution. So we have some array. So let's say like this. And like to check that we have all valid numbers, we actually need, in this case, array would be 3, right? So let's say that we have another array that also with 3 elements. Let's say that we have array with n plus 1, right? So we have 4 elements here, and then we are going one by one, and when we see value, we just update our array with this value, and we should return here an index. So an index would be 2, like a value with 0, actually. So with this case, like additional array, we have time complexity would be n, and space complexity would be also n because we are creating another array. Let's try to think about other letter space complexity. So other solutions that I can see is that we can actually sort our array, right? And we can check, okay, so if this value is on this index, so 0, okay, so it's correct. It's correct. This is not correct. So we are missing actually index 2 here. 2. So with this one, we are missing 2. Yeah, because we sort them, and this value that we are missing actually is the value that we need. So time complexity in this case would be n log n, and space complexity would be n. Okay. So actually, I think we can improve even more. If it's a binary search, we can sort our algorithm and do a binary search here. How we can actually do this? So for example, we have this array, and we sort it first. And here we see that n equal to 4, and we missed value 3. Let's say that, let's say, like this. So we have n equal to 5, and we missed value 4. So when we are in this position, and we see that, and with binary search, actually, what we have, with binary search, we have left and right element, right? So we take the middle element and we check if the middle element is on this index, like it has 2 and it's on index 2, so it's incorrect position. Then we are moving our left pointer, because all elements on the left would be also in the correct position. Okay, after this, we are taking 3, for example. And we check, okay, 3 on correct position or no? And we see, yeah, it's still in correct position. So we go to 3. And then we check this value. Okay, so this value is in correct position, no. So, so in this case, we move right. And when we have these things like 2 pointers here, actually we should return if value is not equals to index, then we return pointer left. If it's equal, then we return pointer right. Let's consider another test case. So here we have 6 elements, and we missed 5. So results should be 5. So again, let's do binary search here. So with binary search here, we are finding the first 2. Like how we do this? Actually, we take like 6, right? And divide by 2, it would be 3. So 0. No, actually should work differently. So let's take the left would be -1, and right would be length of our array. So in this case, when we take like r minus l and divide by 2 plus l, because we need to shift our left side. So in this case, when we have r equal to 6 and this one equals to -1, it would be 7 divided by 2. It would be 3, right? And plus L, so -1 it would be 2. So we are taking 2 in this correct position. So we just take 2. Then we again calculate from 2 to this one, and we take 4, and we check that 4 in correct position, right? So we move this one, then we take 6, and we see that 6, okay, it's not in correct position, so we move our right pointer, and then we have like this. Okay, so in this case, time complexity would be n log n, still for our sorting, plus log n. Here, it was plus n, because we are iterating, and space complexity is still constant. Here it's constant as well. So let's try to implement this sorting approach. Okay, so we have our left, as we said, that it would be -1. Also, we have right, it nums length, and we are iterating while right minus left is greater than 1. So, yeah, when we are not in this position. And here we try to find middle element, so it would be right minus left divided by 2 plus left. So we have our mid position. Then we are moving our pointers here. So if our nums mid, so our mid element that we are taking is mid element is equal to mid, right? So mid in this case it's mid index, not mid value. Yeah, so if nums is let's say greater than nums than mid, yeah, then we should move right pointer. Here we should move left pointer. And in the end, we should return whether left or right. So if nums left equals to left, then we should return right. Otherwise, we return left. Okay, so let's try to debug this with this test case that we have. Okay, so my left would be -1, and length would be, in this case, 9. Okay, so 9 plus 1, 10 greater than 1, calculating mid, 10 divided by 2, 5, -1, 4. And our nums mid, in this case, 4, 0, 1, 2, 3, 4, it will be 3. First, yeah, I missed that I should do sorting for nums. So I have my certain nums. So my certain nums would look like this. So it would be 0, 1, 2, 3, 4, 5, 7, 1, 0, 1, 2, 3, 4, 5, 6, 7, and 9. So I missed 8 here. Okay. So I take 4. So 0, 1, 2, 3, 4, 4. Yeah, I take 4, our mid index. Mid index in this case is not greater than mid. So I move my left pointer here. My left pointer would be not moving like this, but like this. So I move my left pointer to 4. Okay, So now here my left pointer and here my right pointer. Okay, I calculate again my mid. So in this case, it would be 9 minus 4, it would be 5. 5 divided by 2, 2 plus 4, 6. Okay. So in this case, it's 4, 5, 6. So I'm taking this 6. And I check. If 6 is equal to 6, greater than 6, no. So I'm again move my left pointer to the 6. And right pointer would be here. Here it would be 6. Again, calculating 9 minus 6 would be 3. 3 divided by 2 would be 1. 1 plus 6 would be 7. So I take this 7. Yeah. Yeah, and 7 is also correct. So I move my pointer here to 7. So let's check. Okay, so again, 2 divided by 2, 1. 1 plus 7, 8. And here I actually check that 9 is greater than my mid 8. So I move pointer here. And in the end, I see that nums on the left is equal to left? No, so I return right. Well, otherwise return left. Let's check. Yes, it's accepted, and let's submit it. Okay, so we have problem with test case when we have 1 nums equal to 1. Okay, so let's do it like this. If nums length equal to 1, I just return what I should return. Let's check. Okay, so if it's equal to 1, I should return 0. So I should check. Okay, nums 0 equals to 1. I should return 0, otherwise should return 1. Let's try. Okay, submit. Now I have 1 and 2. I have missing numbers, so index -1 out of bound. Okay. If I will always return right, for example, okay, yeah, so right is correct. Okay, so here I see that it beats 28%. So we have another solutions here. So another solution is, oh, it's interesting. So we can solve it even differently. How can we solve it? So we are taking n. N multiplied by n plus 1 divided by 2. It will be our total. And then we just iterate once. And we total -1 and at the end. Yeah, so it's kind of arithmetic progression, I think. Really nice. Yeah, I think it's could be solved like this. Why? Let's try to analyze this code. So when we have, for example, some array 1, 2, 3, 4, and 6. Now let's say like 0, 1, 2, 3, and 5. So we have 5 elements, and we missed 4. So what we can do, here we have n equal to 5, right? And what we do, we multiply by 6, divide by 2. Okay. 5 multiplied by 6, so 5 plus 1, divide by 2. And then we have this total values, and we just take out each of these values. From total. Yeah, so here we actually add to this value another value and divide by 2. Yeah, do we have some editor, some solutions? Oh, we also can do XOR. Nice. So basically, is the XOR operation. We all know that A, B equal to A, which means 2 XOR operation with the same number will eliminate the number and reveal the original number. Okay. 3 different proportions: XOR, sum, and binary search. Yeah, with binary search we should sort it for sure. If array is in order, I prefer binary search method. Otherwise, the XOR method is better. Yeah, but still, it's yeah, we need to find it during the interview. Gaussian sum for this is this formula. The missing number function taken order, reduce complexity, space complexity, reduce methods. Okay, so I think that's all for today. Thank you and have a good day.